Okay, you guys. So there is a way to find the rate of change of these exponential functions, which is basically kind of like the slope. The only thing is if, as you've noticed with our graphs, they're not straight lines, right? They're not straight lines. However, there is a way to find the rate of change. But if you notice, I'm trying to find my paper from before. If you think about the graphs that we've been drawing so far, the slope from like this area is going to be different than a slope in this area, right? So kind of as you go through the graph, the slope is going to actually be different if you could imagine this as parts of straight lines, right? So it is a little bit of a process that we need to talk about because there will be times to find rates of changes between certain parts of our graph. Okay, so label your notes average rate of change Okay, and the average rate of change is the slope of the line between the 2 points of interest on the curve. Okay, so it's the slope of the line between the 2 points of interest. So we are going to be looking at the graph and focusing in on 2 points and finding the slope of those 2 points. That'll be our way of kind of finding the rate of change. And because these are exponential functions, there will be certain points where the rate of change isn't very big and other points where it gets big. And that's where our line starts getting steep or flat, right? And kind of like when we talked about our exponential functions at the beginning with like the zombies, where it starts out kind of slow and then all of a sudden everyone's a zombie, right? Like what? Like coronavirus, right? We talked all about different how viruses work, right? So you can see that with these exponential functions, the rate of change is going to change. And that's why we focus on 2 points of the curve. So we're just going to review for a second rate of change. It is the slope, right? So it's the change in the y over the change in the x. And these triangles are not meant to signify like geometry triangles. That's the Greek letter delta, and delta means change. So this is like the mathematical way of saying change of the y's, change of the x's. Some of it, yeah. I could make a dad joke. Say it's Greek to me. Huh? Nothing, yeah. It's bad. I said I could make a dad joke and say it's Greek to me. But yeah, I don't know. If you guys are into dad jokes. You can do that. Like I'm into good dad jokes, I guess. I don't know. That was a bad one. All right. So change in y over change in x. What would be familiar to you guys would be the slope formula. If we can reach back in the memory, it was the second y minus the first y over second x minus the first x. Does that ring a bell?
Yes.
Yes. Might be a bell you don't want to revisit, but it's back. Yeah, it's back. All right, so we are going to use what we know about slope to find our rate of change of these exponential functions. So technically, it's really not a lot of new information. It's taking our new graphs and using old things that we know how to do to get what we need done. Okay, so for our first example, we're going to draw a curve. It's not going to be perfect, but just draw kind of a rough coordinate plane. Just for time purposes. And we're going to draw a curve. That's kind of, again, it doesn't have to be perfect. It doesn't have to look exactly like mine. Just try to have it close. Just so that the points that we put on here kind of make sense. And we're going to plot 2 points, and this is not drawn to scale or perfectly accurate. But the goal is to just have an idea of how to find our rate of change. Okay, so draw that curve, label the points. So our job when we want to find the average rate of change, because remember there could be other points on this graph, right? I could have a point here, I could have a point here. And if we look at the different, you don't have to plot these other points, but if we look here, the rate of change here, this is kind of flat, but from these 2 points, it gets kind of steep, right? So it does change throughout the graph. Now, the definition is taking the slope between 2 points of interest. So in this case, these are our 2 points of interest. Okay, it's hard to find the slope of a curve, so what we do is you imagine a line going through the 2 points. So kind of draw a line between those 2 points. And our goal is to find the slope of this line. If we find the slope of that line, we find the average rate of change. That's why it's average. It's not just rate of change. It's the average rate of change. We're kind of taking it and assuming that if I take those 2 points, if I average out as the curve changes, I'll get a basic slope. All right. Now, the thing is you'll be told which 2 points to pick. Right, so if you're given a curve, you'll be told which points that you want to find that average rate of change from. The way you're told will be different though. So sometimes you're going to see the directions given a little bit differently. Sometimes you'll just be given the 2 points on a line. Okay, sometimes you'll be given a table and told which points to compare. Other times you'll be written in something called interval notation. So that's what we're going to do on this part. So you're going to write your directions. Find the average rate, of change. Okay, so average rate of change. And the way this is going to be written is, like I said, it's in something called interval notation. We'll explain what it means in a second. I'll give you a chance to write that down. So interval notation is another way of writing an inequality. The inequality that would match this interval notation would be one less than or equal to x less than or equal to 3. This is interval notation. This is written as an inequality. You're going to see both, especially like a lot in algebra 2. Okay, so what this means is the bracket means the 1 is also included. And this gives us a range. It says that our x's are going to start at 1, and the last point is going to be when x equals 3. So we're starting when x equals 1, and we're ending when x equals 3. Okay, so that's the point where x equals 1, and that's the point where x equals 3. When this bracket is closed like this, it means it's also included. If it looked like a parenthesis, that means it's not included. More notation for you guys. I believe on what we're working with, you're only going to see it closed like that. Okay, so this is basically telling us I want the ordered pair x equals 1, and I want the ordered pair where x equals 3. Okay, so this is telling us we want these 2 points right there. Okay, so that notation says I want these 2 points when x is 1 to when x is 3. Yes?
So it doesn't necessarily tell you the y if x is supposed to be
It does not tell you the y's, it's just telling you which points to refer to. So you'll be given the ordered pairs. There might be different situations where you're given the y's, but when we find our rate of change for this, you're just given the x's. So for example, it would be like if you had one of these other curves that we did yesterday. There are 3 points here, right? So if I said find the average rate of change and you saw this notation, oops. If you saw that notation, that's telling you that I want you to find the rate of change from the point that starts with x equals 2 to the point that is x equals 3. So that means I want the rate of change from these 2 points. So you ignore the last one. Does that kind of make sense?
Yeah.
Okay, so you'll be given the points and then you'll be told which ones you need to compare. All right? Yeah, that's probably the hardest part about this is just kind of getting your head around all the different notation. All right, so having said all that, all we have to do now is take the 2 ordered pairs and find the slope. Okay, so we're going to find the slope of the ordered pairs 1, 4 and 3, 1. Okay, so second y minus first y over second x minus first x. So 1 minus 4, second y minus first y, second x minus first x. So the average rate of change between those 2 points is negative 3 over 2. And again, that becomes important when you have a lot of different points on your graph. Certain parts will be super steep, certain parts won't be steep. All right. Okay, next example. So that was example 1. Example 2, same kind of thing we're gonna do. I'm gonna draw a rough sketch. This time we'll show a growth sketch. And again, not drawn to scale. And we're going to find the average rate of change. And we could just say ARC, average rate of change. Just to save you some pencil. And I'm going to say 4, 7. So even though there are only 2 points you're given on this graph, we're just reminding you I want the point that starts at x equals 4 and ends at x equals 7. Okay, so we're going to get the point that starts at x is 4 and ends at y is 7. So we're looking for the slope of the line if I were to draw one through these 2 points, right? If I find the slope of this line, that gives me the average rate of change. All right, so we take our 2 points, we find the slope. Now, I'm going to write the ordered pairs out just so you have it, but if this feels comfortable, then you don't have to, write those points down. That's what we're going to do. We're going to find the slope between these 2 points. So second y minus first y, second x minus first x. Or you could say 16 minus 1 over 7 minus 4. Either way, as long as you start with the same point, right? So if I start with 16 and subtract 1, I start with 7 and subtract 4, if you want to keep everything positive. but it's up to you. So the average rate of change is 5.
It's positive.
It's positive. Okay, not bad, right? Now, a couple things to remember when we had slope. The larger the number or the further away from 0 our number is, the bigger the rate of change is, right? The steeper our line's going to be, right? So in your assignment, this is used a lot with real life situations, okay? So you won't see this a lot where it's just like find the average rate of change. There's a reason we find the average rate of change, and that's usually with situations. But for now, we're just gonna kind of go through the processes. So something else you're gonna see is you'll be given information in a table. Okay, so our next example, we're gonna see the points in a table. So this would be like you collected data on something happening. So we have 0, -2, 1, 0, 2, 6. All right, so my numbers are getting bigger here. So these would be like ordered pairs. 0, -2, 1, 0, 2, 6, 3, 24, 4, 78. So if you were to graph these, those would be points on your curve, okay? And so we want to find the average rate of change of, I'm gonna give you 2 different sets of points. So situation A, I'm gonna write as an inequality, just so that we can see what this looks like in both ways. So this is saying I want the average rate of change when the x values are between 0 and 2, including 0 and 2, right? So that means I'm starting when x is 0 and ending when x is 2. So these are the 2 points of interest for part A. Now I do have a point in between, but I'm not worried about that point because our points of interest are the 2 end points. Okay, so the points at each end are the ones that I'm going to use to find my average rate of change. Okay, so for my slope, this is ordered pair 1, this is ordered pair 2. All right, so we're going to find the slope of the points 0, -2, and 2, 6. Those are the points we want to find the slope from. So go ahead and do that. And see if you get the same thing I do. Did you get 4? All right. So the second one we're going to do, part B, we'll write as an interval. Okay, so the second set of points are going to start when x is 3 and end when x is 4. So that's these 2 points. So again, if we had a bunch of points in between, we would ignore them for this part. They're important to our situation, but for our rate of change, we want to find it from 3 to 4. So we're going to find the slope of the point 324 and 478. Okay, so find that slope. Did you get 54? It's huge. Okay, so remember, the further away from zero the rate of change is, the larger the change was that happened, or the faster the change was. So if for whatever reason this was showing the growth of something over time, from like, let's say it was, amount of, or like your bank account or whatever. Your bank account is growing because you have stocks or whatever it is, and you started off with $2 negative in your bank account, and each month you tracked how much money you had, or each day, right? So from your initial amount to the second day, you had a growth of 4, but from the third day to the fourth day, it was 54. So that means that I grew kind of slow here and then really, really fast, right? 4 doesn't seem like it would be slow, but in comparison to the 54, it's slow, right? If you can imagine the graph of this, it would be a growth because my numbers are getting bigger, or they're getting further away from zero, right? Or wherever my baseline would be. So if this was my curve, it might, look like that. And this might be the point that I got my 4. And, this might be the point that I got the 54, or something like that, right? So kind of keep that in mind. The further from zero, the faster that growth is. All right. So we're going to quick talk about the assignment because we're ready to actually just start it. Now you'll notice on the board, it says 1 through 11, and then there's an option. I'll explain that in a second too. Let me put your name on this and get it. All right. So what you're going to do on this page is you're going to do 1 through 11. And just to kind of get you an idea about 1 through 5, again, like I said, this is usually used, bless you, with real life type situations. So the first part says, below is a graph and table for 2 runners running the 40-meter hurdle race. They give you a graph, and then they give you a table. Okay, so you'll be able to see runner A on the graph and runner B. You can kind of visualize what happened with the runners, right? She started out fast, kind of steadied out a little bit, and then went faster. She kind of had a steady pace, right? If you look at the table, this is the time, so that's like the X value, right? If we look at the graph, that's the X, or time. And these would be the Y values for runner A, and these are the Y values for runner B. Number 1 says, which runner has a faster average speed for the first 9 seconds? So the first 9 seconds would be this period in time right here, right? Which runner had the faster average speed? So you're going to have to find the average speed for runner A and then for runner B. For runner A, you have ordered pairs. These are your ordered pairs, 0, 0, and 9, 20. For runner B, your ordered pairs are 0, 0, 9, 1, 20. Kind of see how the table's laid out? So just to kind of get you the info, runner A, the first 9 seconds, their ordered pairs would be 0 and 0 for the start, right? And then 9, 1, 20. And for runner B, B starts at 0, 0, and the second time we have is 9, 1, 20. So they happen to have the same ordered pairs. So who had a faster average speed? Neither. They had the same speed, right? You could go through and do the math and see for sure, but because my ordered pairs are exactly the same, they would have to have the same average speed, right? On number 2, who has the faster average speed from 9 to 20? So that's on your table. You'll compare these two. So for runner A, your two ordered pairs are 9, 120 and 20, 168. And for runner B, it's 9, 120 and 20, 213. So can you kind of see how the ordered pairs match up in that table? Bless you. Okay, so you're gonna have to go through and answer those questions. Who wins the race? How do you know? You can use the graph, you can use your average speeds, you can use the table. It's up to you how you decide. Number 6 through 11 are just like examples 1 and 2 we did in the notes. Okay, so 6 to 11 are just like the notes. They give you the points and they tell you the intervals. Okay, go to the back side. On the back side, there are two options that you have. You can either choose to do 12 through 14, or you can do 15 to 16. So it's two different word problems. You decide which one you want to do, based on whichever you think is easier, more interesting, whatever. The first one gives you an equation. You fill out the table from the equation so that you can answer the questions. Second one, you've got a graph. I don't really think one is harder than the other. It's just your option. You don't have to do 17. All right. Okay. So I'm going to pass back. There's a quiz I have for you guys from like 2 weeks ago that I thought I passed back that I never did. I'm going to get you guys that back. And then the quiz you just took, I should have back tomorrow. I'm almost done grading all those. And the final quiz I believe is going to be Friday, just so you guys know. So I believe most of the rest of the practice test can be done at this point. All right, so you want to start kind of working through the practice test questions. I'll know for sure tomorrow, but I'm pretty sure what we're testing on Friday covers what's left. All right. But again, I'll have more info tomorrow for you guys. That's it. Go and get started, you guys.